Hello guys and welcome back to my videos, and we are discussing about multi-threading in Python, and today we are going to talk about async IO in Python. So async IO is actually asynchronous input output, and it is often referred as async IO. It's a programming paradigm that allows a program to perform other tasks while waiting for IO operations to complete. So IO operation means it could be a file operation, it could be a console operation, or it could be a network operation. It's particularly useful in scenarios where IO operations such as reading, writing, as I have mentioned, file or making network requests can be time consuming and might otherwise block the execution of the program. So if you have developed any desktop application or mobile application, then you might have seen these warnings or errors that please perform this IO operation in background thread or don't perform IO operation on main thread, right? So, and to solve this problem, what we have to do is we have to use or we have to perform this time consuming IO operation in parallel thread, and we take that result from parallel thread. Suppose if you are developing an application which requires network operation, which brings data from the cloud and it shows on in your app, then you need to create one background thread, then perform that IO operation, and from that background thread you need to give that result back to main thread, either via, let's say, database or maybe some looper. So something like that we have to do. But this is the traditional synchronous IO, okay, where program execution is halted when waiting for an IO operation to finish. So this means that if a program is waiting for the data from file or network, it cannot perform other tasks during that time. So on the other hand, now let's talk about asynchronous IO, which enables the program to initiate an IO operation and then continue with other tasks without waiting for the operation to complete. The program can periodically check the status of the IO operation or receive a notification callback when it's finished. So this allows for better resource utilization and responsiveness in application, especially in scenarios where multiple IO operation can be handled concurrently. So yeah, so asynchronous IO is mainly used, as you must have understood, that it is mainly used in network application, web servers, and where responsiveness and scalability are important. So many programming languages these days support this framework, asynchronous IO, and with that, Python also supports async IO module that we are going to talk about today. So without wasting time, let's start. So I have created a new project which comes it has created by default these commands and main method. I'm going to delete it, and what we are going to do is we are going to create main method, but this time we are going to use here one keyword, that is async. Okay, async. So I'm telling compiler that this method is asynchronous process, as we talked about. As I have mentioned, this method is supposed to perform. Although we are not currently going to perform any network operation, we are just going to mimic, or we are going to, let's say, going to write a program, producer consumer, and you can assume that this is a IO operation, dummy operation, where it's a time consuming operation. So yeah, so let's create a queue. So I'm going to create, so it's async IO dot queue, and we need to create two methods, right? So again, I must create async definition producer, which takes queue. So this is consumer. Same, let me copy paste this code. Okay, and how do we write this code? How do we run this code? So first we need to use async IO dot run, and here we are going to start with main method. So this is how our program is going to start. So this is a skeleton. I'm going to start with main method. So let's assume that producer is going to produce some data in just like previous example, and consumer is going to consume some data. That main is a parent future task, and which is going to create producer and consumer, and which should be collecting result from this producer consumer. And once both these async tasks are finished, then we are going to complete this main task. So let me create producer task. So we create producer task. So instead of creating now thread, I'm going to create a async definition. Let's pass this queue. And similarly, what I'm going to do is, yeah, it's consumer. Okay, both tasks are ready. And as I mentioned, what we are going to do is we are using another keyword await. So what await keyword does is, so whatever task that comes after await, so let's say I'm going to click on print. So this await, whatever task or whatever operation I'm asking after await, so this main, which is asynchronous, it is going to pause its execution till the time the next operation which I'm going to mention is finished. So I'll explain this again. So here I'm going to perform gather operation. So it basically going to gather result, or rather it will wait for this both tasks to finish, and then it will resume its execution, which is actually it will end its execution. So here I can print both task finished its execution. Okay, both task as in producer and consumer. All right, now let's add some code in producer. So in producer, again I'm going to create loop. So yeah, now here is a tricky part. So what I need to do is I need to put data queue dot put some data, that is I, but here the put operation is IO operation. It is considered as IO. What I'm going to do is I'm going to add await keyword. So what this producer task will pause its execution till the time this data queue dot put operation finishes its execution. So next up is again we are going to sleep, right? So here what we are going to do is we are going to sleep this task. So there is a we have to use sleep method from async IO, and here we are going to sleep our task for 1 second, and finally to finish the execution or to inform consumer that our execution has been finished, I'm going to put none object. So we are, if none object comes up, then we are going to exit this for loop in consumer which we are about to write. So this is like while true, which could go on forever, but element that we are reading. So again, we are going to use await data queue dot, we are reading element. So get method. So await, again, this consumer task will pause here till the time the data queue dot get finishes. So now you can see that we don't have to write here try and except block. We can go here and print element, and after that I can mark that this task is done, and if element is none. Okay, this line. So what I'm supposed to do is I'm supposed to break this loop, which is we are done with processing consumer. Now we can quit. So this is how our program is going to look like. Let's run this. So 0, 1, 2, 3, 4, and none, and then both producer and consumer task finished its execution. So this is like join method, but this is completely asynchronous context. So that is what we have to understood. So this is about async IO that you can use in your program. But remember that async IO is just a paradigm, and the thing we discussed in multi-threading, the limitation of Python multi-threading, that is GIL, that we discussed in previous session, it is still applicable for asynchronous IO also, that only one thread is executed at a time. So although there is going to be just one thread, and that we have to remember. So if you want to know more about GIL, that you can please watch our previous video of multi-threading in Python. You will understand. So thanks for watching my video. Please like, share, subscribe. Thanks once again.